So today we're going to look at the second part of section 2.2, which is on unit circle trig, except we're going to look at some of the angles besides just the quadrantal ones. We're going to start to look at the 30s, 45s, and 60s. So in order to work with these angles, okay, the 30, the 45, and the 60, there's something we have to know about them. It's the same thing we had to know for every problem we did yesterday with unit circle trig. What do I keep saying is the most important thing you have to know about an angle to do unit circle trig? You have to know what about it? Yep, the coordinate. Okay, so that's going to be the big thing that we figure out today. What is the coordinate for 30 degrees? What's the coordinate for 45? What's the coordinate for 60? The first time through, we're going to figure out what the coordinate is. But once we know it, we don't really ever want to have to try to figure out the coordinate again. We just want to write it down and just try to memorize it. So we're going to start with figuring out the coordinate for 45 degrees. So what I've done the best I could is I drew my unit circle. The positive x-axis right here would be 0. Going straight up is 90. So 45 is halfway between 0 and 90. Now, just as a reminder, Ben, what's the coordinate for 0 degrees?
0.
Yep, 1, 0. And James, what's the coordinate for 90?
0, 1.
Yes. Put that here, 0, 1. So sometimes when I ask what the coordinate for 45 degrees is, some people say, well, it's 1, 1. How come that wouldn't work? Yeah?
Because if it was 1, 1 would be a square.
Yeah, 1, 1 would be like the corner of a square. 1, 1 is not on the circle. If you go right 1 and then go straight up 1, you're like over there. Okay, so it's not 1, 1. It is two numbers that are the same, but it's not 1, 1. So what we're going to do here to figure this out is we're going to start by drawing a line from that point to the origin, and then draw another line straight down. Okay, I just created a triangle. And the goal is going to be to figure out the lengths of the two sides of that triangle. If you can figure out from here to there how long it is, that's the horizontal distance that you have to move to get to this point up here. That's your x value. And then, if you can figure out how tall the triangle is, that's the vertical distance to get to that point. That's your y value. So we just have to find the length of the bottom, and then we have to find the height. And that's my x and my y value for the coordinate. So I'm going to draw that same triangle again off to the side, but I'm going to make it a little bigger so I have some more space to work. So this angle in the corner, that's a 90. And the angle by the origin is 45 degrees. Because I know I tilted the hypotenuse at a point right at 45. Now, what's this angle at the top? What would that have to be? Jess?
Is that also 45?
Yeah, how come the one at the top has to be 45?
The whole thing has to equal 180.
Right, all the angles in the triangle have to add up to 180. We know that the one in the corner at the bottom right is 90. We know the one in the bottom left is 45 because that's the angle we set our hypotenuse to point at because we're doing a 45-degree angle right now. We're going to do the 30 later. So the bottom two angles add up to 135. Subtract that from 180, and that'll tell you what the top has to be. So it's also 45. Now, there's one side in this triangle that we already know. The hypotenuse of this triangle, if you imagine it being back in the circle, is really what? Hypotenuse is also it's my radius. Okay, the hypotenuse is the radius, and this is a unit circle. So what's the radius of a unit circle? Pete?
Never mind.
No. Help them out? Yeah, Autumn?
1.
1. So we know this side is 1 because it's the radius. So I'm just going to copy that over to here. Okay, so now let's look at that 45, 45, 90 triangle. It's not just a triangle. It does have a special name because of some of the angles inside it. Anybody remember what kind of triangle this is? Yep, Don?
Is that a right triangle?
It's a right triangle, and there's even another word we can use to describe it. It's a certain kind of right triangle. Because this is also a right triangle if I did something like this. But it's not the same kind of right triangle as that one. You want to tell me what kind of right triangle this is? Yeah?
Is it an isosceles?
Yes, it's isosceles. What does that mean?
2 of the angles are the same.
Yep, 2 of the angles are the same, which also means what? Okay?
Both of those sides have to be the same length.
Both of the sides are going to be the same. So we don't know the coordinate for 45 degrees yet, but we know the x value and the y value, when we write them down, are going to be the same. Since we don't know what they are right now, let's use a variable to represent the base. So this is x from here to here. Since the bottom, we're going to call it x. And the height, we just said it's the same because it's isosceles. What letter should I use for the height? Yeah?
X.
I should use x again because it's the same. If you pick a different letter, you're saying the height is a different value. It's not. It's the same. Okay, so that's also x. Now all we have to do is solve for x. And whatever x is, that is the value that I need to write in both parts of my coordinate because they're the same. Does anybody remember a formula you can use on a right triangle to find out how long one of the sides is? Pete?
The pineapple. Pythagorean theorem.
Yeah, the pineapple theorem, or the Pythagorean theorem.
Right.
All right, so let's use the Pythagorean theorem and fill in what we have, and then go from there. Raymond, can you remind us what is the formula for the Pythagorean theorem?
I don't even remember.
You don't remember? Can anybody remind us, James?
A squared plus b squared equals c squared.
And can you explain what those letters are, since I don't have A, B's, and C's up here?
The 2 legs of the triangle equal the hypotenuse. Oh, the 2 legs squared equal the hypotenuse squared.
So the sum of the 2 legs squared equals the hypotenuse squared. So he said the 2 legs, those are on the left, and the hypotenuse is on the right. So Colby, what am I going to replace A with?
Would you put an X?
Yep, I'm going to put in an X. And Lacey, what am I going to replace B with?
Wouldn't it be X again?
It's going to be another X. And we're going to replace C with 1. Okay, it's a perfectly solvable formula because there's only one variable in it. So we'll simplify and see what we get. All right, Jacob, when I have x squared plus another x squared, how many x squareds does that give me?
4. Or 2.
2. 2 what? 2
X squared.
2x squareds. So when you add them together, you get 2x squared. The only way the exponent would change is if you multiply them. That's when you can get like an x1 and a 4. Okay, but we're just adding them up. And we can do 1 squared. You get 1. Cassidy, what would be my next step here to get x by itself?
Divided on both sides.
And what would you divide by?
2x, or 1.
If we divide both sides by 1, it wouldn't do anything since dividing by 1 keeps everything the same.
2x.
So what would be your next step if you had this?
Oh, divide by 3.
You always divide by the number that's in front of the variable. So same idea here.
2.
Divide each side by 2. That's gone. Okay, I'm just going to move over since I don't have much more space going down. We get x squared equals 1/2. Okay, bottom, what's my last step to get x by itself?
You have to square x squared and 1/2.
I do agree we have to do something to x squared and something to 1/2. Can you say it again, what we have to do?
Square root.
Square root, yes. So we're going to square root both sides. And the way you square root a fraction, you do the top and you do the bottom separate. Top, bottom. And let's simplify what we can. Square root cancels out. And then in the top, Jess, what's the square root of 1? 1. And in the bottom, we can't simplify the square root of 2, so unfortunately we just have to leave it. But that's a lousy place to leave a square root, because we're not allowed to leave it in the bottom. So how do I, to get my final answer, how do I fix this so the square root is not in the bottom? 15?
Multiply the top and bottom by the square root of 2.
Yeah, we're going to multiply the top and the bottom by the square root of 2, and this will give me my final answer. In the top, I have 1 times the square root of 2. And how about in the bottom? What's the square root of 2 times the square root of 2?
Square root of 4, which is times 2.
Square root of 4, which is 2. So now, we just solved for x. If we go back to our diagram, x is the distance from here, which is the origin, over to here. That's the base. The horizontal distance is square root 2 over 2. So we're going to fill that in because we know the bottom is square root 2 over 2. That's the horizontal distance. What's the vertical distance that we have to go up? Or in other words, what's my y value? Yep, Ava?
Square root of 2 over 2.
Good, it's also square root of 2 over 2. That's the distance from here to there. Only reason they were the same is because it was isosceles. Okay, and that's your coordinate for 45 degrees. And that never changes on a unit circle. It's always going to be square root of 2 over 2, comma, square root of 2 over 2. And if you look in the notes, I think example 2 from yesterday was this problem. We found the 6 trig functions of this coordinate. But I gave you the coordinate. And some of you kind of knew, I think I asked, do you think you know what the angle was? And somebody guessed 45. But now you know where the root 2 over 2 comes from. It comes from Pythagorean Theorem. Okay. So any questions on that coordinate? All right. Now that we know the coordinate, we don't want to have to go back through all that again. So we're just going to remember that that's the coordinate. All right. Let's do this. Find 6 trig functions of 45 degrees. All right, so Matteo, what am I missing here if they're asking me to find the 6 trig functions of an angle? What do I need to know? And that doesn't just apply to this angle, it applies to any unit circle trig problem you have to do. You always have to know what first.
The 6 different formulas.
So we're going to need the 6 different formulas, but we're going to have to plug numbers into those formulas. Where do those numbers come from?
The unit circle.
They come from something on the unit circle. So like, how are we gonna get the numbers that we need for this one? What would you do? It's 45 degrees, but we need the numbers to plug into the formula.
I don't know what it's called, but like would it be like P equals and then the
And what is that thing that comes after the P equals? That's a
coordinate?
coordinate, exactly, good. We're gonna need the coordinate for 45 degrees. So if we don't know it, we have to figure it out again. If we do know it, we can just write it down. What's the coordinate for 45 degrees? About Katrina.
Square root of 2 over 2, square root of 2
Yep. And now, we'll go through and do this, but we already did this problem in the notes yesterday. This is example 2. But we can practice it again. The only difference is this time you had to figure out this coordinate. I did not give it to you. All right, so let's start with our sine. How about, Dom, what's the sine of 45 degrees?
Square root of 2 over 2.
Yep, and which one did you pick, just so I know?
The right one.
Yep, the y value.
Yeah.
Okay, so the sine is root 2 over 2. Pete, how about my cosine?
Same thing.
Same thing? Which one did you pick this time?
X.
The x, good. Root 2 over 2. Okay, Olivia, how about my tangent?
negative, or the square root of 2 over 2, and then the square root over square root of 2 over 2.
Yep, so it's the square root of 2 over 2 divided by the square root of 2 over 2, so we're dividing two things that are the same. And what do you get when you divide two things that are the same? 1. Okay, so now we've got the 3 on the left. Angelina, what do we do with the 3 on the left to get the 3 on the right? Just take each one of those and, yep, flip them. Let's do the cotangent. That's an easy one to flip. When you flip 1, you get 1. All right, Ben, how about my cosecant? What are we going to start with?
You just flip so it would be 2 over square root of 2.
Yep, we're going to get 2 over square root of 2. And then, can anybody fix that for me and tell me the final answer? Yep.
2.
What is it?
2.
It's not going to be 2. You're close, Ben.
Is it 2 square root of 2 over 2?
It's 2 square root of 2 over 2, and that even simplifies a little bit.
Square root of 2.
Square root of 2, yes. So square root of 2. And then because the sine is the same as the cosine is the same as the secant. So those are the 6 trig functions for 45 degrees. Any questions on that? All right. So let's take a look at the 30 and the 60. So we're going to kind of do the same thing. We're going to have to figure out the coordinate first, and then we can go through and do them and see what happens. All right, so same kind of diagram. I got my unit circle. That's 0. That would be 90. So 30 is less than half, right? 30 is 1/3 of the way, rotating counterclockwise through the first quadrant. So 30 would be about right here. All right, I'm going to do the same thing. I'm going to make a triangle by drawing a line from where I think roughly 30 degrees is to the origin, and then straight down. this angle, this angle in the corner, that's my 90. The angle near my origin, that's the 30, because that's the hypotenuse, angled 30 degrees to point right at 30. And then how about this angle at the top? What's that going to be? Yeah, Jamie?
It's gonna be 60.
That's going to be 60. So let's draw it on the bigger triangle so we got a little more space. All right. Now, there is one side of this triangle we can label the length of already. What side in this triangle do I already know the length of? Yeah, Angelina? I know the hypotenuse again. And how long is it? It's 1. Yep. Okay, now is this, is that triangle isosceles? No. All the angles are different, which means the sides are different. So don't do this, but if we tried to use Pythagorean Theorem right now, it wouldn't work yet. Because you'd have to call this side x, you'd have to call this side y, and the problem is now you have 2 different letters. We can't solve the Pythagorean Theorem if there's 2 letters. You can only do it if there's 1. So we're going to have to figure out one of these other 2 sides a different way first. And then, once you know one of them, then we can get the last one with Pythagorean Theorem. So this is an example of a special right triangle. And the relationship between the sides in a 30, 60, 90 right triangle is pretty common. If you know what it is, then we could write it down right now. If you don't know what it is, then we can figure it out. So I'm guessing a lot of people probably don't remember that from geometry, what the connection is between all the sides in a 30, 60, 90. So I'm going to give you a hint at how we can figure it out. It involves, you have to be a little clever to think of this. It's not hard once you see it, but you would have to be a little clever to think of what I'm about to do. I'm going to start, I'm just going to group all that together. And then I'm going to go like that. Okay. So any thoughts what I can do with that to somehow figure out one of these other sides? Okay.
I was gonna say that it makes more.
Okay, you could make a rectangle. I think if you flipped it, you'd have to flip it like that, and then I think you'd have to flip it one more time. So you could kind of make a rectangle. Yep, definitely a rectangle. And what would you do from there? I don't know either. I'm not sure. So you could put the triangles together that way, and you can make a rectangle. I'm not really sure what we could do from there. But I do like the idea of putting the shapes together. Does anybody have another thought? Aiden?
If you flip the triangle horizontally and put them together, it makes a large triangle.
Okay, I do want to make a larger triangle. But I'm going to flip it vertically, okay, instead of horizontally. So I'm going to go like that. And I'm going to put that like that. All right. Somebody tell me what's happening now. If we look at what we just created. Vivian?
It's like an equilateral.
It is? Yeah, it is an equilateral triangle, right? 60, 60, 60. Perfectly, it's an equilateral triangle. What do we know about an equilateral triangle? What makes something equilateral? James?
All the sides and angles are the same.
Yeah, all the angles are the same, all the sides are the same. And that's the important piece. All the sides are the same. So the side up at the top we have labeled 1. This side at the bottom is labeled 1. We can also label this side as 1. Okay, so we know that that right-hand side is 1. Any other thoughts? Angelina?
We can assume that the short side is 1/2 then.
Why? Why does this side have to be 1/2?
Because if you put them together and it's only equilateral, it's only 2 of them together, and 1 divided by 1/2 is 1/2.
So can you tell me again why this has to be 1/2? Why not 0.25 and 0.75? Because that would add up to 1 as well.
Because they're equal lengths.
Right, they're equal lengths. These triangles were copies of each other. All I did was take one of them and flip it. Does flipping a triangle change the size of it in any way? No. It just makes it upside down, but it's still the same. So we know this side is congruent to this side. It's exactly the same. So if you've got two sides that are the same length, and we know the total length is 1, then each one of them would have to be 1/2 and 1/2. Now we just figured out one of the other sides in the triangle. We can get the third side using Pythagorean Theorem. Okay, I don't need that bottom triangle anymore. You can keep it there because it's in your notes. I'm going to move it off to the side because I need more space to write down here. Let's just move off what I don't need. And I know that side's 1/2. Now I'll call the bottom side x. And let's set it up with Pythagorean Theorem. And let's get our third side. Hey, if we wanted, we can write down part of the coordinate for 30 degrees right now. Which part of the coordinate do I know? The x or the y value? Yeah, Pete?
The y, which is 1/2.
Yep, I already know the y. That's how far up you have to go. That's 1/2. What I need is how far over. That's the x. Okay, so let's set up Pythagorean Theorem with this. How about, Jacob, could you tell me, using this triangle, how I could set up Pythagorean Theorem?
X squared
Good?
plus 1/2 squared
Yep, perfect.
equals 1.
1.
1 squared.
1 squared. In this case, it doesn't make a difference, but if it was anything other than 1, that would be very important. All right. So, we've got x squared plus, what's 1/2 squared? Which means half of a half. 1/4 equals 1. Right, next step, I'm going to bring that 1/4 over to the other side. And Lacey, if I bring that 1/4 over to the other side, what's 1 minus 1/4?
Wait, what?
What's 1 minus 1/4?
I don't know.
So think about if you had like a circle divided into 4 pieces, and you took one of the pieces away. How much would be left?
3/4.
3/4. Okay, 3/4. So x squared equals 3/4. And Cassidy, my last step to get x by itself.
So divided by 1.
So remember, dividing by 1 wouldn't change anything because dividing by 1 is like multiplying by 1. It keeps it the same.
So it would be 3/4.
Well, we still have to get rid of something on the left-hand side. What do we have to get rid of?
The squared.
The square. What's the thing that gets rid of squaring?
Square root.
Square root. So we're going to take the square root of the left, and we're going to do it on the right. Square and square root cancel. Autumn, can I take the square root of 3 and get a nice answer? No, so we're just gonna leave it. Can I take the square root of 4 and get a nice answer? 2. And there is my x value. The square root of 3 over 2. And that is the length of the bottom side of the triangle. And that's my coordinate for 30 degrees. Now, we're going to look at the coordinate for 60, but it's not going to be that much work to figure out the coordinate for 60 because of all the work we've already done. Let's put 60 right about there. And let me draw the triangle for 60. It looks kind of like that. Does anybody see a connection between the triangle for 60 and the triangle for 30? Yeah, Colby?
It's the same triangle, it's just rotated.
Yeah, it's the same triangle. It's just the 30 and the 60 switch places. Now, the angle down here is the 60, and the angle up at the top is the 30. So, based on the angles just kind of switching places, like the triangle is standing up rather than laying down, anyone think they have a guess what the coordinate for 60 is? Angelina?
1/2 the square root of 3 over 2.
Oh, very good. 1/2 square root 3 over 2. So all the coordinates we've done today, all the work we've done, it really boils down to 3 numbers you have to remember. Root 2 over 2, root 3 over 2, and 1/2. Those are the only 3 numbers you have to remember to do everything that we're doing in class today and for tonight's homework. Now, the only thing that can be a little tricky about the 30 and the 60 is just remembering which one is which. Well, here's how you can remember which one comes first. Let's look, let's say we had a 30-degree angle. When you draw your 30, there's definitely one side in that triangle that's longer than the other. In this case, it's the bottom. The bottom side is longer. The height is shorter. It's smaller. I know that I'm going to be using these 2 numbers, root 3 over 2 and 1/2. Well, if you type this in on a calculator as a decimal, it's exactly 0.5. If you type in the square root of 3 and divide by 2, you get about 0.866. So root 3 over 2 is a bigger number than 1/2. It's a little bit, it's the bigger one. So the bigger side is always the bigger number. So in this case, the bigger side is the bottom. It would be the root 3 over 2. The height is my shorter side. Shorter is smaller. It's the smaller number. So this would be my 1/2, which we usually write as a fraction. So now I can say the coordinate for 30 degrees would be root 3 over 2, comma 1/2. With the 60, it's just the opposite. Now the short side is right there. The shorter side is always the 1/2. The longer side is always the root 3 over 2. So if you ever get mixed up which one is which, try to draw a diagram and find where the short side is. That's your 1/2. Any question on that? All right, so let's find the 6 trig functions for pi over 6. Okay, so 6 trig functions of pi over 6. What's the first thing that I have to figure out to do this problem? Yep, go ahead, Ian. I gotta have the coordinate. To get the coordinate, it might be easier to change that to degrees. Hopefully we're kind of starting to remember some of these now, because remember pi is 180. So what would that angle be when you change it to degrees, Jade? 30, correct. That's my 30-degree angle. So now I just kind of visualize it in my head, and I try to figure out, okay, where's the 1/2? Where's the root 3 over 2? You're not using root 2 over 2. Root 2 over 2 is only when you have an angle that's a 45. Okay, that number is not involved in this. So think about it like this. Here's your 30. In this case, that's my long side. That's my short side. So what's going to be my coordinate for 30 degrees? Yep, Jess?
Square root 3 over 2.
So the long side is the x. Short side is always the 1/2, and this time the short side is up and down. That's the y. All right, now we've got our coordinate from here. It's just like a problem we did yesterday. So we'll do the 30 together, and then I'll let you guys try the 60 on your own. And that'll be it. All right, so let's start with my sine. Ava, what's my sine going to be here?
It's gonna be 1/2.
Good. It's the y value, which is 1/2. Right. Olivia, how about my cosine?
Or root 3 over 2.
Yep. Cosine is the x. X is root 3 over 2. Now my tangent. Pete, how do I get my tangent? What's my formula for tangent?
Y over X.
It's y over x. So that's 1/2 divided by root 3 over 2. Okay, I'm going to do that over here. Okay, anybody remember, you can flip and multiply. Does anyone remember the trick I said yesterday? What's going to cancel out here? Yeah, Raymond?
The 2's are going to cancel out.
2's are going to cancel out. So at this point, all you're left with is 1 over square root 3. And how about, Ben, what do I have to do to fix that?
Multiply by square root of 3 over square root of 3.
Perfect. Okay, so remember, this is what we had, and we're fixing it by multiplying by square root 3 over square root 3. James, what's that going to give me for a final answer?
1. No. Wait. 1 over the square root of 3.
So that's what we had, and then Ben told us how to fix it so we don't have that square root at the bottom.
I don't know.
Yep, Eva?
Square root of 3 over 3.
Good. Square root of 3 over 3. Now, what's in this green box may come in handy in a minute. Okay, so don't like erase it or throw it away. Keep it there. We'll come back to that. Now, we're going to take the 3 on the left. We're going to flip them to get the 3 on the right. So Cassidy, what's my cosecant?
2 over 1.
2 over 1. So we can simplify that and just say 2. My secant is going to be 2 over the square root of 3. Anybody fix that up for me and tell me what I would get when I don't have the square root in the bottom? Yep, on.
2 square roots of 3 over 3.
Perfect. 2 square roots of 3 over 3. And now let's look at the cotangent and try to think about this in kind of a smart way. We have 2 answers for the tangent. We've got the one I circled in black, which was the final answer. And then we had the answer we started with, which was the one in green. You can flip either one of them, but one of them would be less work. Yep.
Would we flip the 1 over the square root of 3 just to get square root of 3?
Yeah, exactly. If you flip the one that's in the green box, which is exactly the same as what's in the black circle, one in the green box makes the square root go to the top, and you're done. If you flipped the one that I have the circle around, the square root would go back to the bottom, you'd have to fix it all over again, and you'd still get the same thing. All right, so those are the 6 trig functions for 30 degrees. Okay, any questions on those? All right, I want you guys to try the 6 trig functions for 60. See if you can find 6 trig functions for 60. And then what I'm going to do once you guys do that is we're going to compare the answers that you just got for 30 to the answers that you get for 60. I want to see if there's like a pattern that happens. Okay, and then we'll look at that pattern, and then that'll be it. All right, so let's take a look at finding the 6 trig functions of 60 degrees. What's the first thing, how about Dom, what's the first thing you have to do here?
So you take the coordinates from 30 and you
Yep.
flip them.
Yep, so for 60, the coordinate, the x and the y switch. So now, the short side is on the bottom, and the tall side is vertical. So what's my coordinate for 60, Dom?
That would be, the x is 1/2.
Yep.
And then the y is square root of 3 over 2.
Yeah. So since the x and the y switch places, we're going to see a lot of the same answers because they're the same numbers. They just switched. So Vivian, what's my sine?
Square root of 3 over 2.
Square root of 3 over 2. Yep. Ben, what's my cosine? 1/2. And my tangent? You can almost imagine just going like this. Imagine putting a fraction line right there, because that's your y, that's your x. Just divide them. When I divide them, Raymond, what ends up canceling out?
The 2's.
The 2's. So all I'd be left with is square root of 3 divided by 1. So that would give me square root of 3. And when we flip them, we're going to get the same answers that we had in different spots. That's going to be 2 root 3 over 3. That one's going to be 2. And the last one is going to be root 3 over 3. Now, compare that to the 30. Does anybody see a spot where 2 answers switched places? Anybody see 2 functions where the answers switched? Yes?
Sine, cosine, and then
Yep. These 2 switched. Yep.
and then the ones right next to
And do you remember what those are? Anyone remind what's CSC? Yep, Autumn.
Cosecant,
And SEC?
secant.
Secant. These 2 answers switch places. And then these 2 answers switch places. So the ones that I put boxes around like that, if you look at the functions that switched, they're actually spelled very similar. Sine, cosine, secant, cosecant, tangent, cotangent. So the ones that switched are all the ones that had the word co in front, switched with the one that didn't. We'll talk more about that not this week, but at some point. So, homework for tonight, and again, I'll put this up in the video. The worksheet is online, so you get that on Schoology. Lesson 2.2, Part 2, it's a PDF. There are 10 questions on the worksheet. And then there are 5 additional questions that I have on the board right here. So you can either copy these 5 down now, or just pull it up on the video on YouTube or Schoology.